This is problem 9 from chapter 13. The conveyor belt is moving at 4 meters per second. If the coefficient of static friction between the conveyor and the 10 kilogram package is 0.2, determine the shortest time the belt can stop so that the package does not slide on the belt. If we're looking for the shortest time in which the belt can stop, that means the force of static friction is going to be at its maximum value. If you stopped the belt really, really slowly, then you wouldn't have to worry about the package slipping. If you stop it really fast, you're going to need as much static friction as you can possibly get to keep the package from sliding. So, if you look at the forces acting on the package, you have the force of gravity acting downwards, which is the mass times g. The mass is 10, so this is 98 newtons. You have the normal force acting upwards, and if the package is going this way to begin with, and then it is going to come to a stop, you need acceleration going in the opposite direction, because when something's slowing down, the acceleration and the velocity are in opposite directions. So if the acceleration is in this direction, you must need a force going in this direction. You only have one force in the x direction, and that is the force of static friction. If you sum up the forces in the y direction, because the acceleration is equal to 0, you get that a normal force is equal to 98 newtons. Therefore, you can say the force of static friction, which was not on the equation sheet, and it was in the textbook, and it wasn't even very prominent in the textbook, but this was on page 121 in the green box. They said the force of friction is equal to the coefficient of kinetic friction times the normal force. That gives you the force of kinetic friction. If you want the force of static friction when the particle is on the verge of moving, then you should use the coefficient of static friction. But this is when it's on the verge of moving, which means the force of static friction is at its maximum value. So we have the coefficient of static friction times the normal force. So that's 0.2 times 98, which is 19.6 newtons. So now I can look in the x direction. Sum of the forces in the x direction is equal to the mass times the acceleration in the x direction. The only force I have acting in the x direction is this force of static friction, which is 19.6. That's equal to the mass of 10 times the acceleration. Therefore, the acceleration in the x direction is equal to 1.96, and it is acting in the positive x direction. To find the time, well, this is a constant acceleration, so do I have anything that will help me for constant acceleration on my equation sheet? Well, it's dv dt, but for constant acceleration, that would just be delta v over delta t. So delta t is equal to delta v. Oh, I know what equation we could use. We could just use equation 12.4 and rearrange it, but it doesn't really make anything that much easier. So we'll stick with this. Okay, so delta v divided by the acceleration, which is what we would get from rearranging this equation here. V final is equal to 0, so this just becomes 0 minus the initial velocity, but the initial velocity is in the negative direction, so that would be minus -4, or you could say +4, divided by the acceleration of 1.96, which gives you a positive time, which is good. And that is 2.04 seconds. So delta t min, which we find using the maximum value for the force of static friction, is 2.04 seconds.